Hello everybody, my name is Andrija Kretalic and I'm coming from the University of Zagreb, Faculty of Geodesy. In this session, I will introduce you to the basics of photogrammetry and remote sensing. We will start the story about photogrammetry and remote sensing by defining the broader term, Earth observation. So, what is the Earth observation? Earth observation can be defined as acquiring information about planet Earth's physical, chemical and biological systems by remote sensing technologies. The term Earth observation primarily means information collected from the Earth observation satellites. However, this also includes data collected by other platforms, such as helicopters, airplanes or drones, and also terrestrial measurement. As part of Earth observation activities, monitoring of individual objects or phenomena on the Earth's surface is carried out. Their changes in time and impact on the environment are also observed. You probably know many of the Earth observation applications, such as weather forecasting, an activity that is hard to imagine without satellites nowadays, tracking biodiversity and wildlife trends, distinguish land use change such as deforestation of urbanization, monitoring and responding to disaster, the floods, earthquakes and tsunamis, managing energy sources, fresh water supplies and agriculture. So, the main idea of Earth observation application is to capture in a very short time an abundance of data on a large area. This can only be achieved by remote sensing methods. The umbrella organization that unites experts in the field of photogrammetry and remote sensing, ISPRS, defined these two fields of science with a common definition until 2016. So, photogrammetry and remote sensing is the art, science and technology of the obtaining reliable information from non-contact imaging and other sensor systems about the Earth and its environment, and other physical objects and processes through recording, measuring, analyzing and representation. Until that time, photogrammetry was more widely used. But with the development of the remote sensing, that is the reduction of the spatial resolution of satellite images, over the years, since 2016, each area has its own definition. So photogrammetry is defined as the science and technology of extraction reliable, three-dimensional geometric and thematic information. The focus in the distinguish is on extracting reliable data that must provide measurement images and measurement models, in which dimensions and distance of the objects in space can be measured. The accuracy of the measurement depends on the scale in the image or model. On the other hand, remote sensing is defined as the science and technology of computing, processing, and analyzing imagery in conjunction with the other physical data of the Earth and the planets, from sensor in space, in the air, and on the ground. Remote sensing focuses on the radiometric presentation of objects and the possibility of highlighting them in images. Spatial accuracy is not important, but it is secondary. Due to the very fact that some satellite images have a spatial resolution of 10 like Sentinel-2 or 30 meters like Landsat sensor. Let me state some basic facts about photogrammetry. Photogrammetry is the science and technology of obtaining spatial measurement and other geometrical, reliable derived products from photographs. It helps in obtaining information about the physical object and environment by collecting, interpreting and measuring the photogrammetric images. In simple terms, photogrammetry is the science of photo-based measurement. Photogrammetry provides geometric concepts for generating accurate 3D models, and then digital elevation models, orthophotos and thematic GIS data are created from it. Photogrammetry can be divided in two types, depending on the position of the sensor, camera, aerial and close range or terrestrial photogrammetry. In aerial, the camera is mounted on the aircraft and is pointed vertically towards the ground, and in terrestrial photogrammetry, camera is located on the ground. One of the tasks of aerial photogrammetry is the planning and implementation of stereoscopic data collection. It is planned to collect overlapping images in parallel sequence strips that also overlap. The following rules must be ensured from such recording and producing 3D models. The longitudinal overlap of the images must be at least 16%, and the transversal or overlap of the images must be at least 20%. Only under these conditions can usable stereo models be produced. Geometric distortion occurs when the sensor is creating a matrix image. Center projection causes radial distortion of objects that is directed from the center to the edge of the image. You can see example of this on this slide, perspective view and image in upper and lower right corner. In the process of orthoreflexification, the central projection is transformed into an orthogonal project that is an oblique project into an orthogonal one. On this slide, you can see some more examples of central and orthogonal projection and the result of the orthoreflexification process. Now, the stereoscopic photogrammetric measurement ensure the creation of various types of 3D digital models. The digital terrain model is a three-dimensional image of a large land surface. The digital terrain model contains information about the heights of a particular area without displaying artificial object and greenery. A digital elevation model is a digital model of three-dimensional representation of a terrain surface created from elevation data. And the digital surface model is a digital elevation model of the shape of the surface, including vegetation and infrastructure. Similarly, terrestrial stereoscopic photogrammetry is a technique that creates a 3D point cloud of objects. Photographs taken from different angles are used in that process to create a three-dimensional representation of an object. Such a model is called a measurement model, on which object can be measured and mapped in a given scale. And now, remote sensing has some other task, and basically it's about digital image, or collecting, processing and highlighting objects of interest in the scene. One task is developing a space mission and design a spacecraft and instruments to operate with the mission. The next technical task are the use of sensor for data collection and transmission of data collected by sensor on the satellite to the ground station. The main task of remote sensing is the interpretation and processing of images and analysis and visualization of results of that processing. Finally, tasks are archiving and managing this data for scientific and public user. In the end, let's repeat the objectives of the activities within the remote sensing methods. Tracking specific object or phenomena of interest on the Earth's surface and its impact on the environment. The second is detection and extraction of objects of interest in digital image and or classification of digital images. For the successful implementation of remote sensing method, it is necessary to define a list of indicators for a certain phenomenon that can be seen in the image. An indicator is an object on the ground that gives an expert for a phenomenon the right to draw conclusion about phenomenon. For example, if some kind of military fortification object, like trench, is visible in the picture, it can be concluded that there are landmines at some distance from it. For the effective use of photogrammetry and remote sensing, the key activities is a good definition of the problem and the user's need for data about an area or phenomenon. That would be all for this presentation. Thank you for your attention and see you in the new representation.